Thank you for introduction, and thank you very much that I have the invitation to come to you, to this audience, and talk about future technology. Please allow me to start to introduce myself. I'm having my own consultancy office, and I'm consulting automotive industry, truck industry, mobility solutions for motorbikes, and agriculture tractors. And my history is I was in former times head of design of AVL, that is an international company to design and develop engines. And this was my first cooperation with the new material, compacted graphite iron. There I learned CGI, and I learned SinterCast, and I learned Steve Dawson. And I was responsible for the first engine which came into mass production. That was a 3.3-liter Audi V8 diesel. This was the first engine ever produced with CGI material from SinterCast. Later on, I went to the maritime industry. I was head of R&D of MAN diesel. And there I learned Lars Hallberg, who was my competitor, but we also worked both together in a European research company. And from there, I made diesel engines and gas engines and electronic control system. Then I was head of research of MAN trucks. And here again, I had a chance to work with CGI material because the engines have to be very compact because of the different bodies you can install in a truck. And in parallel, I was responsible for truck race, and CGI material also helped to increase the performance of the engine very much. So we had to use serial production crankcases and cylinder heads, and we ran them more than 70 kilowatt per liter, which is enormous for a truck engine. Later on, I was responsible for Deutz engines, and these are industrial engines installed in tractors and machines. And here, again, SinterCast helped me to solve a problem. We had a cylinder head which was too weak for the high performance of the Fendt tractor, and so with CGI material, again, we could succeed. And the last 3 years, I was head of AVV, also an engineering company, a little bit smaller than AVL, but similar. And here I was responsible for motorbike up to ship engines, and very often we used this material. So that brings me to the point where I would like to give you a presentation about how I see the future of mobility. I would strive shortly history and boundaries. I would discuss electric powertrain, which is of interest, I think, today. Then I come to really senseful mobility solutions and a future energy mix. And at the end, I would say, yes, there is a future for combustion engine beside electric drives. So I will hurry a little bit because we don't have so much time. In the history, you see land transport was done by animals, so they're also a little bit autonomous driven. So if the driver cannot go home, the animal finds a way. And on the sea, we have a wind situation. Then the steam engines came to sea till the diesel engines occurred at 1912. And then the cars for passengers were originally in the 20s luxury goods. They turned to come to volume production to make everybody here in Europe able to run a car nowadays. In the 60s, there was a belief that there is enormous energy and you can run the engine and the car with any speed. There was also a wish to fly with the cars. And in 1958 already there was a wish that the car could have an autonomous drive. So these are all the features in the 60s. In the 70s, we learned that energy is limited. The cars, the streets were empty, 73. Then the safety discussions started about the cars. Then the emission discussions, we got all catalytic converter in our engines and cars. And today we have the CO2, the greenhouse discussion, besides the diesel discussion itself. And the reason, of course, in the climate we see a change. We see that if you look the CO2 emission over the years, we overcome it in the last time, and the temperatures are increasing. So even there is not a real proof, we as engineers should fix the situation that way, that we use as less CO2 as possible. I think this is a sensible thing to do. And you see it here in the graph. We do now everything. The industry try everything and give limits to reduce the CO2 emission. So what is the future of mobility, and what will the future bring? And is the future electric drive? So at first we have to define, is electric really a future thing? And you see in 1900, the first vehicle coming to a speed of 100 kilometers was an electric-driven vehicle. So at that time it was usual to have electric cars. They were more easy to drive. So in the 20s in USA it was very famous, that car going by electricity, mainly for cities. And in the 50s, transporters in Germany already had electric drive. And when there was the Olympic Games in Germany in 72, a lot of companies had to show electric-driven cars because they wanted to go with the marathon people, and they don't like to have too much emissions around them. So also transporters were electrified. So the technology is not a new one. And the technology itself has a big burden, like a battery power density is very much limited. The battery costs, the lifetime of a battery. The infrastructure of power supply is very complicated to give enough loading station to everyone. And today we turn to the situation that we change the discussion coming from well-to-wheel discussion up to life cycle assessment. And we look what is in the life cycle of a battery, what materials we will use for batteries, and so on. So coming to the problems, you see 100 and 200 watt-hour per kilogram is the target we have today. And we want to have future targets to 300, 400, 800 seems for me too optimistic to bring it into industrialized products. And if you look now to a diesel engine, which is typical in a tractor, you see you need for around about 600-liter diesel to run this tractor 10 hours a day. And the tractor is running most of the time followed such a large tractor by going over the fields. And so the tank is designed that way that you can store 600 liters. If you would do it electrified, you needed a battery, a modern battery of that size. That means it is not practical. It would also have the same weight as the tractor itself. You would have needed an additional trailer to bring the battery, so nobody will use that. And when you think in the transport situation of large ships, and 90% of the goods are transported via the oceans, with ships with diesel engines, so you cannot imagine to have electrified ship going a long distance. Then let's look to the peripheral situation. On the right side, you see in Germany situation, we have 14,000 pump stations with over 90,000 pumps. That means we can have an energy exchange every day of over 900 gigawatt. To come with electricity, we have a lot to do to bring all in all 240 gigawatt that the cars can be loaded and the batteries can be loaded. In Germany, we have a huge discussion that we need 2 new electrified lines from north to south. It will need years till we get that. If we would do everything electrified, we could use, for example, windmills like here, then we would have to have every 2.5 kilometers a windmill. And if we want to have the electric current through Germany, we would add, besides the 2 new lines, we have to add more than 30 lines from north to south. That means that is a big burden for everybody to really make it happen. So let's think about a future technology, and the future is not electrical drive only. This is not the golden bullet to solve all problems. So we need in the future a linked advantage of different powertrain systems. And there electricity has a certain role, an important role to play. So the mobility solutions of the future should look like this. I would show you the transport chain of goods. Normally the goods come over the seas with a huge carrier of containers, and they will increase so much that at the end there will not be the space in the harbor of a city to load this. So you need maybe platforms offshore in front of the coast, and there you have a chance to go with the large ships with a huge amount of containers. These ships will have still two-stroke engines like today. They will be a little bit larger than today, but still the same. This will be two-stroke diesel engines with exhaust after treatment, which is new, and with more waste heat recovery system to have really the lowest fuel consumption which will be possible. And then this big load will go to smaller container ships, which are called container feeders. And this smaller container can go into every harbor and also to rivers. And this will have four-stroke engines with diesel, but also for gas application that will differ, and also dual fuel, so to have different fuel as a possibility. The next is that you need harbor shipping, you need such city harbor boats, tugboats, and these tugboats will also have four-stroke diesel engine, also possibility to drive with gas, but they will also have electric hybrids, so that in the inner field of a city, this tugboat is able to drive with electricity. And then the goods have to go over the road. Of course, long-haul trucks still will have diesel engines, but they can be electrified as mild hybrid, for example. Waste heat recovery will be up to date. And then it comes to smaller delivery trucks, the good. This will have diesel or fuel engines, and also can be as a full hybrid, that the truck is able to go with an electric motor into the city to run the last mile. And the smaller delivery vans, which is going from house to house, can be fully electrified. That makes sense from energy side. Looking at the passenger car, and please look at the red parts. These are components which are electrified. This is a mild hybrid car. You can increase the hybridization by having a really hybrid, a plug-in hybrid, and at the end you have a complete electrified car with only electric motor and no combustion engine. And you easily see that the design of the cars will change, because you need a lot of space for the batteries, so the whole body of the car will change in the future. So from the energy side, it's really sensible to have electrified cars, but it's sensible if you have a small distance to go and a small size of the car. A small size of a car needs lower volume of batteries, which can be faster recharged. And the longer the distance is you have to drive, the more interesting is to have a combustion engine. And in between, the gasoline hybrids makes really sense for large cities. As you are in Seoul or Tokyo or New York, there really gasoline hybrid makes sense. The same is passenger car transport with buses. The smaller the bus is, the more electrified it can be. And at the end, there are a lot of concepts where an electrified small bus can go autonomously through cities in limited areas. And the more you have a longer distance, the larger the body is of the bus, and the more a diesel engine is again interesting for such an engine. And looking at the pharma industry, I had shown you the example with a large Fendt tractor. This will be a diesel engine also in the future. But the smaller the application is, the more you have a small tractor which is not doing so much energy, it's not consuming so much energy because it's not plowing over the fields, it's doing small work, delivery of trailers and so on. The more it can be hybrid or fully electrified, and there are concepts where there are only small electrified tractors, and you come with a trailer to a field. open the trailer and 50 small cars go out and go to the field. That is the other way around. You can also do field work. And this is an interesting concept which may also come in the future. So at the end, a diesel engine with a hybrid makes really sense to electrify the engine, the combustion engine, to have a starter generator, start-stop system, electrified accessories, helps at passenger cars also, as it helps also for big industrial or truck engines, which are also introduced with Deutz as a hybrid system, and it makes sense for combustion, for construction equipment like an excavator, where you have so much additional things to do, which you can do easily electrified in the future. So what future energy mix I see for the future? And here again a similar picture on the right hand side. You go in that direction, that you have here more mileage to do, and here more weight to do. That means more energy. And here in the far corner is the ship. The ship will need fluid fuels, and the same with airplanes. Airplanes are in a similar area, and you also need fluid fuel for aeroplanes. There is no alternative solution for this. And the more you come to the far left side, the more electricity is interesting for use. So we will have in the future a big variety of different energy sources to fill into machines and cars. So one thing is very, very interesting for the future. It is a synthetic fuel. Why to use all the time fossil fuels from the ground? It's in general better to have a new fuel which is synthetic, and I show later on in an example. This is oxymethylene ether, which is a very good synthetic fuel, and you see it in this example. A normal diesel engine with a diesel fuel, with fossil fuel from the ground, you have all the time the problem that you have to optimize the engine in that way that you have less particulate matters, which you see in that direction, or less NOx emission. So, and with an OME fuel, you have really a clear burning without any additional patterns, and you can go on this line with nearly no particulate matters. So you can optimize such an engine to the lowest NOx emission. Now, how can you produce such synthetic fuel? And there are different ways. The nearest way is around about 2020. You can take renewable energy like windmills or solar power to get energy to make a fuel synthesis, and then you have to produce hydrogen as one element. Then you need another element, you need the carbon. And carbon you can get from waste of industries, you can get it from CO2 from industry, you can also take it with biomass, second generation, all the biomass which you cannot eat or which animals cannot eat. This you can also use, the C atoms, for this new fuel. And in far future, around about 2050, it is expected that you need even more energy, but then you can take the CO2 from the air and use there the C for the new fuel. That is really a good way to reduce the CO2 balance and to have at the end fluid fuel. And this fluid fuel you can use as a drop of fossil fuel today, and you can turn to really an application which is pure synthetic fuel. But for this, we need a standardization of this synthetic fuel, because the engine itself has to be adjusted to that. And if the engine will be adjusted, you only need a special injection system, in the principle the same as you have today, but you have to do another dimension, you have to do other compression ratios and so on. That is not a big deal. So future engines will be prepared also to run with such fuels. And how the whole situation can look like, I show it in this example. You have here renewable energy by windmills and solar power. With that, you go with electrolysis and produce hydrocarbon. With the hydrocarbon, you can storage it, bring it to a power plant and do electricity, or you take it and have a new peripheral situation for hydrogen pumps. On the other hand, you can go this path and make, when you add C atoms, you have then a fantastic fuel, a fluid fuel, which you can use for combustion engine, or you take it and make here this way and combine it with methane. Then you have a peripheral situation for gases, for methane gases. You can also add methane from pharma industry in it. And then you can also take methane and have power plants and again electricity. And with that, you have a situation that you can have a hydrocarbon for fuel cell drives and electric motors. You can use a charging station to have directly electricity for vehicles. And you have a situation to provide fuel for combustion engine. So, how others see the future, and I have two perspectives now to show what is going on in the next year. You see here the number of new sold cars and the way what kind of engine they have. It starts with the year 2000. There we had mainly petrol engines and diesel engines in passenger cars and some small portion of gas engines. And if you look at 2035, we expect even to have more combustion engine than today in the sales, but these combustion engines will be diverse. Yeah, there will be every engine will have a kind of electricity, mild hybrid, really hybrid, plug-in hybrid, or only diesel and petrol engine, and some portion of gas engine. And there will be maybe around about 20 million new engines with pure electrified engines, so fuel cell or battery engines. And if you see the next estimation, where you count every engine which is on the road together, the former picture was only the sales, the actual sales of engines. Here is the counting of all engines running on the street. And then you see in 2035 there will be around about 70 million fully electrified vehicles. But if you compare it to the overall situation, and here in this picture you see that we have in 2035 over 1.8 billion vehicles all in all. And if you see the portion of the electrified, it's still a small situation. But this fits also to the peripheral situation, because you will not get in any corner of the world loading stations. You have to divide big cables everywhere, and so the speed to electrify everything will be lower than today politicians tell us. So what will be in the future? We see, of course, combustion engines which will be improved with electrical drive, and that makes sense, completely sense, to combine a combustion engine with electricity, as I've told before. And the future engine has to be like today, very compact. Compactness of an engine is a success factor. Nobody wants to have a large engine in his car. We all want to use the space for us all and for the goods. Then we want to have high specific performance, because the engine itself should be very small. And it should have in the future a high potential for different applications. As I told you, we will use very different fuels in the future. And this is a picture from Deutz. When Deutz invented the engine itself before 1900, were very low in the fuel, in the performance per liter, but it increased all the time. And the same way is today, the engine performance will increase. Therefore, there are a lot of technologies which today are already in series production, but there will be technologies which come in the next years into a series production. And for time reasons, I will not go through any technology, but it's clear that also the after treatment is today nearly perfect. Also for diesel engine, we all have particulate filter, even for tractor engines. This is an example for a tractor engine. a tractor engine today has also an SCR catalytic converter, has urea to add to the fuel, so that it is a perfect low NOx emission and a perfect low particulate matter emission nowadays. So that in the portfolio of technology, and this is one of my last pictures, here you see the technology in that direction, and here you see the different applications. Diesel engines for large bore, for heavy duty, in truck engines, for example, passenger car engines and passenger car gasoline engines. And here you see in grey color this technology which is today on the road already, and in blue you see expected technologies and technologies where people are working on. And there is so much possible, for example, introducing variabilities like variable valve train. It will be introduced new kind of combustion process called Miller cycle. For this, you need also multi-stage boosting, which is today already in series production. And the next steps are EGR concepts and full variable compression ratio, which is today missing. But there are a lot of development which are going in parallel to overcome this. So I come to my last slide. I have to say the combustion engine still will be evident for the next 30 years at least. Technology packages are in development. The variety of fuels will increase very much, and you will have different local solutions in the future. Compactness of overall package will be a success factor. The company who can produce the smallest engine has a big advantage to others. The power density will increase steadily, but lightweight design is mandatory. This is very important, that the engine has to be as light as possible. And for this, of course, CGI, not only for me personally, was all the time a perfect fit, but in general, it's really a suitable solution for modern diesel engines. So thank you very much for your attention, and for questions, I'm open. Thank you.
Thank you. Well done.